Okay, welcome back, Chemistry 30. So hopefully you had time to look at the next one here. This one is adding ammonia to the system. So it's like saying increasing this, increasing the amount of ammonia. So you can see here that's going to be too heavy on the ammonia side. So if the stress is increasing ammonia, the response is going to be try to decrease it, use it up. And you can see to even things out again, it's heavy on that side, so I have to move away from that. Shifts to the left, and the direction I'm shifting to is going to increase in amount. What I'm shifting away from will decrease, so that means reactants increase, products decrease. Lastly, adding hydrogen to the system. If I look at where hydrogen is, it's on the left hand side. Adding hydrogen will make it heavy on the left. So the stress of increasing hydrogen, the response is going to be trying to use it up, decrease it, and you can see to make things level out again, to make things constant, shift to the right. So if it shifts to the right, everything that's on the right already will increase, everything that's on the other side will decrease. Okay? So there's other things we can do to make it shift to the right. In order to make things shift to the right, the teeter-totter would have to be out of balance. It would have to be heavy on the left. So we could add nitrogen, add hydrogen, remove ammonia, because then it would be light on that side. If this was an exothermic reaction, if I took away heat, it would try to replace it by shifting to the right. And lastly, pressure. You can see I have 4 molecules. 1 plus 3 is 4. I have 2 gas molecules on the right, so if I increase pressure, it would move to the side with fewer molecules, which is the right. So there's quite a few things you could do here to trick the system into shifting to the right to produce more ammonia. Okay, we'll look at the next one. So again, what's the stress, what's the response, the shift direction, and what increases and decreases. Adding water. So you can see water is over here on the right. If we add water to the system, it becomes heavy on the right-hand side. So if the stress of increasing water would try to be relieved by reducing the water, using up that extra water. So you can see here, if I shifted things to the left, everything would be imbalanced again. And if I move to the left, everything on the left will increase in amount. So that means hydrogen and carbon dioxide will increase. When I'm moving away from, the products will decrease in amount. Okay? Maybe you try the next two and see how you make out. Maybe pause the video right now and then come back to see how you did. Okay, if you had a chance to do that, removing carbon monoxide. Here's carbon monoxide, so if I take it out, things are out of whack. It's light on the product side. So I have to replace, no, I have this backwards, I think, here. This should be like this. Decreasing the SCO, or I did have that right, I just had the stress in the different spot. So if the stress is decreasing CO, the response is to increase it again, and I can do that by shifting things to that light side, shifting things to the right. And of course, everything that's on the right-hand side will increase in amount, everything that's on the opposite side will decrease. Last one here, adding hydrogen to the system. Hydrogen is on the left-hand side, so if I add more, it's going to be heavy on that left-hand side. So I need to try to use up that extra hydrogen that was added, and you can see here if I shift things to the right, that will happen. And again, if I'm moving to the right, everything that's on the right-hand side will increase in amount, everything that's on the left-hand side will decrease. Lastly, if I have something that's using up carbon dioxide, it's the same thing as removing carbon dioxide off. So it's going to be light on the left-hand side. So if the stress is decreasing CO2, the response is to increase it again. And I do that by shifting things to the left. So everything that's on the left-hand side, hydrogen and carbon dioxide, will increase in amount. Everything that's on the right-hand side will be decreased. Okay, so those are some examples dealing with concentration. If we look at pressure here, so we talked about what happens with pressure, has to do with the number of gas molecules. So question 7 here, if I decrease the volume, which is the same thing as increasing pressure, how does that affect these? So remember that if the stress is an increase in pressure, to try to decrease the pressure, you move to the side that has fewer molecules. Just kind of reasoning that if we are talking about people, fewer people exert less pressure than many people. So here we have 2 SO2s plus 1 O2, that's a total of 3 molecules. On this side I have 2 molecules, so in this case it would shift to the right, where the fewer molecules are. This one, counting up the molecules, 1 and 1 is 2, 2. So if I increase the pressure here, I'm going to go to the side that has fewer molecules, but guess what? They're both identical. So there would be no shift due to each side having the same number of molecules. Okay, the next one, 2 molecules on the left, 2 plus 1 is 3 molecules on the right. So if I was to increase pressure there, it would shift to the left, to the side that has 2 molecules. So that's how pressure works. Here, temperature. Now I set up this question a little bit backwards. I set it up so that I want a specific answer. What do you do to the temperature in order to get that? So if I want the result of an increased amount of CH3CHO, there it is. I want things to make, so let's say I had a plant that has CH3CHO being produced. If I want to make more of that, what would I do to heat? Now here, heat is negative, so it means it's an exothermic reaction. So what I want to have happen is I want my seesaw to look like this. If it looks like this, then I will cause things to move to the right. And that's what I want to have happen, because I want this to be produced. So in terms of heat, if I can add heat or remove heat, the thing that I would want to do is to remove heat out of there. Remove that heat out. Because when I do, my thing will be out of whack. Here my equation will look like that, and it'll force to the left, to the right, sorry. So if I decrease heat, the system will say, oh my gosh, we've got to increase the heat again, replace it. We do that by moving to the right, and in the process, we achieve the objective of making more CH3CHOO. If I was to figure out the KEQ expression, products over reactants before versus after, if I'm forcing things to go to the right, I have more products, less reactants. The KEQ would go up. So that would be an indication of an exothermic reaction. If removing heat caused the KEQ to increase, that would happen. Now if I want a decreased amount of C2H2, so if I want this to go down, oh, that means I'd want to shift away from it. I'd want it to be used up. So guess what? It's the same as the previous question. If I decrease heat by taking it away, the system says, oh, we have to replace the heat. Let's go in the direction that does that. And it would move to the right, which would use up C2H2. See if you can figure out part C, and then we'll come back to part 3 of the video, the final part, and finish it up. So you try part C, then tune back into the video. See you soon.